Please don't write code like this. Today, I'm going to be showing you the most common programming mistakes that I see literally every single day. At some point in everybody's programming journey, they've made these mistakes, and this video is going to help you fix them very quickly. So with that said, let's get into it and learn about the common mistakes and how to fix them. The first mistake I see time and time again has to do with conditions and if statements. Now, a lot of times there's many different things you need to check in order for a condition to be true or to go into a certain block of code. So I've given you a simple example here. You can see that we're checking if the user is authenticated, if they're an admin or a manager, or they're an editor and they have the permission edit, if their account status is active, if they have a last login, if their age is between 18 and 35, if their IP address is not in this range, and you get the idea. There's a bunch of different conditions, and although this code is fine, it will work, it's not horrible, there's a significantly better way to write it. So let's go over to the fixed version, and now look at this. Now, it's a little bit longer, sure, but don't concern yourself with the length of the code. What we're more concerned about is how readable is the code and how easy can we understand it. Longer code that's easier to understand is always better than shorter, more complex code. So if we go to the top here, you can see that what we've done is we've just associated each condition with a variable. Now, some of them are a bit redundant, like is authenticated, for example. We probably don't need a variable for that. But for the other ones, what this does is just make it a lot clearer on what we're actually checking. So we're checking, are they active? Have they had a valid last login? Are they of valid age? Is there a valid IP address? And what this is doing is two things. It's kind of automatically commenting the code for us because we're writing it like we would write normal English, and we're simplifying some of the longer conditions into one variable. Now, if we keep going, you can see that we have some more complex conditions, like for example, has proper role. In this case, it makes even more sense. We're saying the user.role is an admin or manager, and then we check this. So we've kind of taken this complex condition that might take a few seconds to understand if we're reading it, and we've just wrapped it inside of a variable that defines exactly what it's checking. Same thing for has proper method for the request, for example, and then same thing is suspension compatible. So then we go down here and you can see that we have all of these ands, we've combined them together, and now we can return true. So if I want to see what we're checking in the if statement, I can read this just like English. Are they authenticated? Do they have a proper role? Are they active? Do they have a last login, etc. Now this is a little bit overkill how I've shown you here. I'm just trying to demonstrate the point. A lot of times you'll have multiple different conditions, and rather than checking them all in the if statement, you can make variables to simplify the condition and then combine those variables together to be able to read your code like English, which is really what we're going for. So this next example is a simple one, but so many people make this mistake. Now look at this code, pause the video, and see if you can figure out a better way to write it. Now immediately what should stand out to you is that we've got this kind of staircase going down. You can see that we're kind of going on a diagonal. The reason for that is that we've got a lot of nested blocks. We have if statements inside of if statements inside of if statements inside of if statements. Now for simple code like this, it's okay. We can still understand what's going on, but if we keep going and add more and more ifs inside of each other, it gets really complicated really fast, and we've got all of these levels of nesting, which is what it's referred to, which is just really difficult to read and especially to change or understand what's happening. So you can see that what we want to do here is we want to go through all of the numbers that are passed to our function. We want to make sure, first of all, they're not none, they're greater than 0, they're an even number, and they're less than 100. So what we're looking for is all of the numbers between 0 and 100 that are even, and then we're going to add that to our results list. Okay, that's fine, but it took me a second to understand that because of all of these levels of nesting. And whenever you've got this staircase pattern, it's probably a hint to you that you could simplify the code a lot and make it flat. Ideally, when you're writing code, you want the fewest levels of indentation possible, because the more indented blocks you have, again, just the more confusing the code is. And you've got all these staircase patterns going through, which makes you kind of have to use the mouse and figure out what block is where and what's going on, especially when you start adding, else blocks here and printing other stuff and adding more indentation. It gets really confusing really, really fast. So let's look at the solution here, which is this one. So you can see immediately the code no longer has that staircase pattern, and we've been able to reduce the indentation levels to almost flat. Now you can't always reduce every level of indentation, but here you can see that we only ever have one if statement. We don't have if statements inside of if statements inside of if statements inside of if statements. So what we're doing here is we're using a pattern that's very common. Notice that rather than checking all of the things that I want to be true, I'm actually going to check the things that could potentially be false and result in me not adding this number to the list. This is really common, reversing the direction of the condition to simplify your code. So rather than saying, okay, is the number not none? Like, is it a valid number? I don't check that. I check if the number is none. Now, if the number is none, immediately I know I'm not going to be adding this to my list, so I can just continue. I can go back up to the top of the for loop and try the next number. Next thing down here, I say, okay, let's check if the number is odd. Let's check if the number is out of our range, and if it's either of these, so if it's out of the range or it's odd, let's continue. So I'm going through all of the things that could potentially eliminate this number from getting added to the list, and I'm checking those first, and then if these are not the case, I can simply add the number to my list. So if you look here, you can see the code side by side. Right here, I check if the number is not none. Here, I'm checking if the number is none. If it is none, I can just continue, and that means I can eliminate that level of nesting. Okay, that's great. Next thing, we check if the number is greater than 0, if it's even, and then if it's less than 100. So rather than doing that in 3 indented blocks, I just write a few simple conditions here and I check, okay, is it out of the range or is it odd? If it is, we simply continue. So all of this is kind of eliminating all of those numbers, and then we get to the point where we know we have a valid number because we've already done all of these checks and they haven't been true, meaning the number is valid, so we can add it to the list. I know it's a little bit confusing when you first see it, but this is a really great way to remove those levels of indentation, and it's very common, especially in loops, that you're going to see things like the continue keywords and the break keywords to allow yourself to avoid having all of these levels of nesting. So the next example is something that probably looks familiar to you. I can almost guarantee you that at some point in your life, you wrote code that looks like this. Check it out. What we've got is a bunch of if statements or if and elif statements to check things like numbers. So for example, maybe you want to print out the day of the week and you have days 1 through 7. So what you do is you say, okay, I'm going to write a function. I'm going to check if the day is 1. If it's 1, we'll print Monday. If it's 2, we'll print Tuesday. And you keep going and you check all of the possible options. And sometimes I've seen people have 50 if statements, 100 if statements, checking every possible number that you could have. In fact, even sometimes when I ask people to write programs to check if a number is odd or even, they just write out all of the different numbers they can think of. So numbers, 1 to 100. And if it's 1, they return odd. If it's 2, they return even. If it's 3, they return odd, and they write code like that. It's totally fine. It's a logical thing to do if you don't know any better, but obviously there is a better way. So let's check that out. So here's the first way that you can fix this code. Now what I've done is I've created a dictionary. So whenever you've got kind of values mapped to some other values, like a 1 is Monday, 2 is Tuesday, or something is equal to something else, but you don't want to make all of these different variables or write a ton of different if statements, what you can do is you can kind of map them using a dictionary. So notice what I've done here is I've mapped 1 to Monday, 2 to Tuesday, 3 to Wednesday, and I've written this dictionary that contains all of my keys associated with their values, exactly what a dictionary is used for. And then I can simply get out of the dictionary the key and it will give me the value. So if I say days.week get and then the day number, if this number exists as one of the keys inside of the dictionary, it's going to return me the associated value. So if I put a 1 here, it's going to give me Monday. If I put a 6 here, it's going to give me a Saturday. And if this number for some reason doesn't exist as one of the keys in the dictionary, we'll simply return invalid day number. That's what happens when you use the .get method. Now, if you were to use the square brackets, you'd get an index error or a key error if you tried to access something that doesn't exist. That's why I'm showing you .get. So this is one way you can do these mappings. Now, another way that you can do this is using an array, especially if you're using numeric values. So here's another method that I have. We have this array, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And notice that every single value in the array kind of corresponds with an index, right? Monday's at index 0, Tuesday's at index 1, Wednesday's at index 2. And what we can do now is we can check the day number. So we can say, okay, if the day number is between 1 and 7, then what we're going to do is access inside of our array or inside of our list days of the week and then day number minus 1. Now we've subtracted 1 so that we can associate day 1 with index 0, day 2 with index 1. So we kind of map up, the human readable numbers starting at 1 with the computer readable numbers starting at index 0. So that's another way to do it. Doesn't matter whether you're using a dictionary or a list, but these are things that you can implement to avoid writing all of these different if statements. So just see how much easier it is to understand here, especially with the dictionary example, because I can really quickly see, okay, 4 maps to Thursday, 5 maps to Friday, and if I want to add more, I can just add entries to the dictionary rather than adding more and more and more if statements, which just isn't the best way to do this. Now, another reason why this is better is that rather than having to potentially check every single one of these conditions, what I can do is just very quickly look up the value using this dictionary in what's known as constant time. I can just immediately grab whatever's associated with the number, whereas with the if statements, if I'm looking for day 7, for example, I first need to check if the day is 1, if it's 2, if it's 3, if it's 4, if it's 5, if it's 6, and I have to keep going and check all of the different values, which if you're in some kind of performance critical code is not going to be the most efficient way to do this. Again, if you keep adding values, you got to check every single possible value until you eventually get to the one that you're looking for. Now, the next example I have is something I was guilty of for many years when I was writing code, and that is the mega function. Now, the mega function is just a function that does everything. It's one function to conquer them all, handles every single task, and is very, very confusing, especially when you come back to it a year later. So let's look at this code here. Now, immediately, if I ask you to tell me what this function does in 10 seconds, are you able to do that? Maybe some of you are if you've seen something like this before, but chances are it's going to take you at least a minute or two to read through this code and understand what's actually going on. Now, the purpose of this code is not important. The point is that it takes a long time to understand what it's doing. And when you're writing code, you want that code to be self-documenting. You want it to express really clearly and really quickly what it's doing so that other people that look at it don't need to spend so much time and so much brain power trying to dissect it and figure out what's going on. So if we read through it, we can see that we're first making sure the order is a dictionary. If it's not a dictionary, that's an error. We're also making sure that items is in the order and customer is in the order. If it's not, then that's an error because we need to make sure that we have items and we have the customer. Then we go down here and we say, okay, we're going to grab the total price. I think that's what that's doing. I got to read through this and make sure. We're going to make sure the price is in item and that quantity is in item as well before we do this. Then we're going to see if we need to apply any discount. Then we're going to make sure that we have a payment method. And then we're going to process the payment using the provided payment method. Okay, so I can understand that, but again, like it takes me a second. I'm not 100% sure what's going on, and I've got to read through every single line of code in order to figure this out. Now, worst case, if this function got bigger and bigger and I needed to go in here and change something, like maybe change the way we're calculating the discount or the possible payment methods, again, it's going to take me a bit of time to locate that code, and it's going to be more prone to errors. So let's look at the way that we can fix this. So what we've done here is, yes, our code's got a little bit longer, but we've separated it out into logical functions. So each part of this function now, we've separated into smaller sub-functions so that it's easier to understand and to debug. So now we go back to the original process order function, which is right here. If I want to understand what the process order function is doing, all I need to do is read these 6 or 7 lines of code. So I say, okay, first I'm validating the order. That makes sense. Next, I'm calculating the total price. Got it. Then I'm applying the discount. Okay, makes sense. Then I'm processing the payment. Then I'm sending the confirmation email. Really straightforward. All I did was just read the names of the functions that we're calling, and now I immediately understand what's going on. I don't care about all of the little details and exactly how things are being handled, and if I do, I can go look at those functions, but the point is, in the matter of, 10 seconds, I now fully understand what the point of this function is because of the way that it's written. And this is really the practice you want to get into. Now, obviously, we can go read these individual functions if we want. And now if I want to change maybe how the discount's being applied, well, I know that I'm going to go to the apply discount function. I don't need to look at all these other pieces of code that I'm just not concerned with. Same thing with process payment, same thing with calculate total price. So really what I've done is I've taken this function, I've split it into the different things that it's doing, those independent tasks, and I've put those in their own functions and then kind of combined them in this one call. So the lesson here is whenever you've got these mega functions that are doing a ton of different things, see if you can split them up into logical smaller units of code that not only makes the problem easier to solve, but it makes your code more readable, cleaner, and just easier to understand. Again, look at how clean this function is and how quickly I can understand it. Now, the last major mistake that I see literally every single day is forgetting to check for edge cases. Now, when we write code as a programmer, a lot of times we're optimistic. We just assume that whoever's using our code is a genius, they're gonna know exactly how to use it, they're gonna pass the correct input, and everything's gonna work in an ideal scenario. Anyone who's been writing code for a little bit of time now knows that's just not the case, and a lot of times your code can break in really weird ways that you've never predicted. So let's look at this code right here. You can see that we have a calculate average function. Totally simple. We grab our numbers, we loop through all the numbers, we add these together, and then we divide the total by the length of our numbers. Any normal person would read this and go, okay, yeah, that makes sense. You know, we can get a result like 20 here if we calculate the average of these numbers. But what happens if the length of my list is 0? In fact, we can run this code and notice that I actually get an error, 0 division error. Now, the reason we got that error is because we divided by the length of numbers, and well, the length of numbers was 0. So that's fine, but what happens if we do something like 3, and then maybe we pass in the string hello, and then we run this code again, and notice that now we get unsupported operand type for plus equals int and string. Okay, so there are errors that can occur, and even though these seem silly, when you're running code thousands, hundreds of thousands of times for so many different inputs, really anything can happen. So when you write your functions in your code, you want to be really robust and make sure you're checking for all of the possible things that could go wrong before you start executing it. So let's look at an example where we fix that. Now again, this is a little bit overkill. It's more robust. This function is going to work to calculate the average of any numbers now, and it's going to handle any issues that could occur. So you can see this first line here. What we're doing is making sure that numbers is actually a list. Now in Python, we're working with a dynamically typed language. That means that even if we add a type annotation like a list here, technically people can pass anything to this function that they want. So it means we have to check things a little bit more than we would in a statically typed language like C++ or Go or something along those lines. So first I make sure numbers is actually a list. If it's not, I'm going to raise an error, and the reason why I'm raising an error here is because I want to tell whoever's using this function exactly what's wrong. So that's another note here. If there is an issue, rather than just returning false or some weird ambiguous value, actually raise your own custom exceptions. So in this case, I'm raising a type error and I'm telling them, hey, you called this with the wrong value, fix it. So now they know how to fix their code. Great. Next, we check if the length of numbers is 0. If it is, we'll just return 0 because, well, if there's no numbers, we can assume that the average is 0. We could also raise a value error if we wanted to do that. Depends on what we want the function to be. Next, what we do is we validate all of our numbers. This is one way to do it. There's many different ways we could validate this, and we're going to collect num for number in numbers if is instance num is int and float. So what we're doing is removing all of the invalid instances here, so anything that's non-int or a float, and just keeping all of the numbers. This way, even if you pass a string, for example, but you have some other valid numbers, well, that's still going to work, and we'll just calculate the sum, or sorry, the average of the valid numbers you give us. So we go here, and now again, we make sure that the length of valid numbers is not equal to 0. If it is equal to 0, we simply return 0 because, well, that's the average of 0 numbers. Then we go here, we calculate the sum, we divide it by the length of our valid numbers, and now this function is bulletproof. It works with pretty much anything that we pass it, and if we pass it some invalid input, it tells us exactly what's wrong and how we can fix it. So there you go, those are the major mistakes and how you fix them, and I want to give a special shout out to anyone who's stuck around until the end here, because I know if you've made it all the way through the video, then you're someone who values education and constantly improving. Now, if that's you, and I'm pretty sure that it is, I want to share with you a fantastic resource that you can take advantage of to continue improving those skills. Now, that's Brilliant, the sponsor of this video. Brilliant is where you learn by doing with thousands of lessons in math, data analysis, programming, and AI. They adopt a first principles approach, ensuring you understand the why behind each concept. Every lesson is interactive, engaging you in hands-on problem solving, which has proven to be 6 times more effective than simply watching lectures. The content is developed by top-notch educators, researchers, and professionals from renowned institutions like MIT, Caltech, and Google. Brilliant emphasizes enhancing your critical thinking abilities through active problem solving rather than memorization. As you learn specific subjects, you're simultaneously training your mind to think more effectively. Consistent daily learning is crucial, and Brilliant makes it effortless with their bite-sized lessons, allowing you to acquire meaningful knowledge in just a few minutes each day, perfect for replacing idle screen time. Additionally, Brilliant offers a comprehensive range of computer science and Python courses, as well as extensive AI workshops guiding you from a complete beginner to an expert through practical, hands-on lessons. Try everything Brilliant has to offer for free for a full 30 days by visiting brilliant.org/techwithtim or click the link in the description. You'll also get 20% off an annual premium subscription.